マイクは使わないのことです。
I tried it, but no luck.
Well, today I speak about Qubes OS. So this presentation title is the Introduction to Qubes OS videos. Please do self-introduction. My name is Gome. Twitter's screen name is ntddk, taken from Windows drivers development kit header file. And I'm also undergraduate student of Keio University and researching about security in raw layer such as malware or virtualization etc. And I'm a participant of security camp and also I'm a CDF player at Xen Virtualization. So today I will speak about Qubes OS. What is Qubes OS? Do you know Qubes OS? Qubes OS is a secure VM developed by Filesystem and this concept is security by isolation. And this source code is open source, licensed GPL with. And Qubes OS is based on Xen. So today I don't speak about BI. So wish I could provide some inspiration or idea for you. So what is this single route? This single route is founded by Joanna Rutkowska in 2007. Rutkowska is who forced Citrix to publish source code of Xen client and publish Blueprint when you are in Cosmic. Blueprint is a malware. Blueprint is a virtualization technology-based rootkit. Previous rootkit works on link 0. Link 0 is a kernel mode and rootkit hooks subsystem code or for alternate some kernel structure such as IDT or BCD or IRB something. So we can detect it because there are kernel layer, so we can detect it. We detect from kernel response. Then virtualization technology-based rootkit is on link -1, so we can hardly detect it. There has been many single route has been researched about such low layer security, the rootkit or system management mode or inter-system execution technology. Now they are developing security focused on mechanism Xen. So well, what's the difference between Xen and KVM? So Xen and KVM has some difference about virtualization methods or interrupts or memory mapping. And Xen is a paravirtualization. Xen based on paravirtualization. Paravirtualization hardware on Xen and Xen executes paravirtualized OS. That is private domain, so it called host. And after executing paravirtualized OS, they execute paravirtualized or other OSs that were not non-privileged OS. And then it's originally paravirtualized hypervisor, but with assisted interoperability, then come through full virtualization. And KVM is a kernel module and based on full virtualization technology. So, and Bat.io is an IO library based on paravirtualization. So KVM also uses it. What paravirtualization merit is fast. Paravirtualization is fast because of no need of full hardware emulation. And full virtualization, but paravirtualization have to change OS source code and modify OS for virtualization environment. That's why for virtualization, so for virtualization or then have to use hypercode. So we have to modify OS. And full virtualization is a no need of modifying OS. And the other difference of Xen and KVM is the interrupt method. And Xen uses event channel, and KVM uses MSI. And memory mapping method is different from Xen from KVM. KVM's guest physical memory space is a part of post-virtual memory space of QEMU. And Xen uses other method to mapping memory. Mapping guest physical memory space on demand. So there are difference. Both use hardware-assisted virtualization, such as ntddk or AppVM. So there are decreasing difference of Xen. Well, then what's the hardware-assisted virtualization? What is ntddk? So I talk about it. But today already Mr. Shu talked about this, so I'll make the story as short as possible. ntddk is the motivation is how to handling sensitive instruction easily, how to emulate it, and how to emulate sensitive instruction is a motivation of ntddk. So it is tired to rewriting instruction by hand. So we want assistance of hardware. So ntddk mechanism is below. Roll some settings to VMCS structure and set CPU to VMCS, and VM range from VM range VM entry instruction will execute it and enter VM non-root mode. It's guest mode, and ordinarily we use computer in the guest mode and execute guest environment. When cause some trap some sensitive instruction is a trap, and when cause some trap, exit instruction will execute it and enter VMX root mode. VMX root mode is a big -1. So after entering VMX root mode, check VM hypervisor checks VMX reason and emulation using some handler. So after handling traps exception, VM receivers were executed and VM entry. So OS enter VMX non-root mode. It's again that is guest mode. So executed this string and after execute some handler, so we can loop this routing. Then what is VMCS is a virtual machine control structure that contains program counter for some register and VM memory point. What to trap and enter VMX root mode contains VMCS. And ntddk support EPT. Its motivation is simplifying paging. It is tied to transformation, so we make new shadow page table. And EPT is an extended page table, and address translation by hardware. Before published EPT, we have to address translation by hand at VMM. And but after EPT publish, we can after publish EPT, we needed address generation by hand. It first by hardware. And so by integrity, we can easily make VMM with VMM. So this integrity after publish integrity, we can easily make VMM. So this is the concept of KVM. But then is making before publish integrity. So need of hypercolor using paravirtualization. So KVM is more sophisticated, but Xen virtualization is useful to secure VM, making secure VM. So I'll talk about Xen, how Xen architecture, how Xen virtualization. Xen has a domain 0. Domain 0 is a host and privileged OS, and Xen also have some domain U. Domain U is a guest OS. Xen hypervisor executes domain 0 before domain U. Domain 0 manages other domain U, and only privileged domain is allowed to access all hardware. Domain U asks domain 0 to hardware access via back-end and front-end driver. So Qubes OS applies this architecture to security. Then what is the concept of Qubes OS? Well, desktop think about desktop environment. Qubes OS want to provide strong security to desktop environment. Desktop environment some applications such as spreadsheet and web browser and mail client. So people use different applications there, and also game. So if this game was a malware, want to fork some application or steal some applications settings. So this game was if this game was malware, that causes information leakage. And if they are not malware, but this web browser has some vulnerability, some attacker exploit it, and some settings or information were stolen. So it's painful. So there are two approaches to solve this problem. One first is security by correctness, second is security by isolation. Security by correctness is some code auditing or developers education or testing or safe program language, but it doesn't work in practice. So security by isolation is this account of the security correctness. We want OS to provide isolation between various applications. So if these games compromise, game want to steal some application settings, but there were enabled. If there were enabled some isolation, and this app is cut off. And we want to even decom some apps. The browser contains different uses, such as internal systems to access internal systems or shopping or see the news site or Googling. So we want to decompose some apps to function. So their OSs provides some isolation. Isolation provided by OS is not enough, but there are some isolation provided by OS, such as address space isolation or user account isolation, access control list, kernel user space separation, or change root, systrace, Linux, secure. But they don't work in practice, because if kernel contains some bugs and exploits it, their mechanism, all the mechanism will not work. Monolithic kernels are buggy, and hundreds of third-party driver works on most buggy kernels, so we cannot be made secure. Then Qubes OS virtualization for rescue it. First, I talk about merits of virtualization. Bug or vulnerability is proportional to line of code. And Linux kernel source code is 10 millions of line of code. However, bare metal hypervisor only need 100 kilo line of code, so we can easily come through secure environment by virtualization. So there is a conceptual diagram, and there is hardware and then hypervisor, and its domain 0 is a privileged domain and executes some other VMs. So one AppVM, personal AppVM, random AppVM. They are separated by users' use. So domain 0 provides secure environment and management some other VMs, and does contain network function and storage function, and 25 line of code, so it is secure. And the second domain is executed by domain 0, and it is non-private VM and only supports storage function. And network domain is non-private VM executed by domain 0, only support network function. And AppVM is a main Qubes blocks. It hosts some user applications such as web browser or mail client and games. And we can create VM depending on their use. So one user wants to use one VM to hobby. It contains game program and other uses. So this user wants to access internal system that only contains web browser. So domains are isolated each other, and because this AppVM is secure, and this AppVM created by template VM, that is read only. And AppVM is other specific disposable VM. Disposable VM only supports one application, and if one application with this disposable VM compromised, there are no other information, there are no other application, so it is secure. If I received a mail with a PDF, so if PDF malicious, we cannot protect my information. So when checks the PDF is secure or not, we use disposable VM. And AppVM is a lightweight VM and can centrally operable. And AppVM executes some application, but each app gets a label, that is applied by the window manager running domain 0. Each application executed in separated VM, but user can see it in one desktop environment. And this is a screenshot. And left is a black VM, and right is a Atlasis VM and Wax or Web VM. So each VMs are separated, and but we can see it one desktop environment. So Qubes OS uses GUI Virtualization to control it. This is a domain of application VMs and applications. Some applications uses Qubes OS uses X Windows. So applications memory shared by Xen shared memory, and Xen server works on domain 0. So we can see the application's GUI at the domain 0 or on one desktop. And Qubes OS also think about VM protection. This is important. Some research about concerns VM protection is an overshadow at the SPL 2008. Overshadow gets some context of guest OS from hypervisor and encrypts page at the memory access when malicious software access from hypervisor, but memory was encrypted, so malicious software cannot see the memory, and show correct process to not encrypt the memory, and this research is first of VM protection, and some other research is SP3. SP3 uses memory encryption and set access control per page. So malware cannot see other memory. So SP3 has both encrypted page and non-encrypted page. So it controls deduction of overhead. Then what's Qubes OS VM protection? Qubes OS uses InterVTD and InterText to protect VM. InterVTD can DMA protection, can set VM protection. DMA is a direct memory access with read or writing memory from hardware. So DMA not need of CPU. So how can we protect VM from DMA? And InterVTD can virtualize DMA. So this is mechanism. From hardware, DMA request from DMA request execute from hardware, and DMA remapping engine refers to device assignment structure, and get some translation structure is get from DMA. This mechanism is resembles to paging. Then what Qubes OS Qubes OS hypervisor to protect DMA from DMA it uses InterVTD, and InterVTD can prevent access from other range other than VM after address translation. So with the aid of InterVTD, Qubes OS can establish DMA protection. At a reboot sequence before interpretability initializes, intertext protects VM. So if we cannot use interpretability, the intertext can protect VM. So it is maintain secure environment. Then what is the intertext? There is one concept. It is important on talking about hypervisor security. Trust is a concept that is all workers expected. And so we trust is a base identity and measurement. And first, we have to establish trust. So when we want to establish trust, when we use root of trust for measurement, this is a reliable engine makes a measurement of integrity. And first we establish root of trust, and we repeat trust and establish trust. So we can connect root of trust to chain of trust and connect chain of trust and connect to chain of trust. Then what to RTM is important. RTM cannot measure itself. So RTM the method is RTM is have two methods. First is a strict RTM. RTM is a firmware on the RTM and building chain of trust from booting. So when we boot this computer, so RTM firmware is check drivers or OS kernels, and this is a chain of trust, and chain of trust chain of trust, some chain of trust makes a trust, and other RTM method is a dynamic RTM. RTM is a get-sec instruction and building chain of trust from executing this instruction. So this get-sec instruction enables DMA protection, so we can protect VM. This is a Japanese program, kill two birds with one stone. So we have to use interpretability, but intertext the DMA protection solve this problem. And the intertext uses both static RTM and dynamic RTM. So executed BIOS and chipset, chips executed when we turn on this computer, BIOS chips are executed SRTM and the bootloader were checked, and OS executed the dynamic RTM, so we can maintain trust and maintain secure environment. And this is a thread protection of Qubes OS. First, process tamper module. Tamper module have measures kernels. And second, kernels loaded on domain 0. Domain 0 is a private domain. And third is ask for passphrase on smart card secret. So it maintains secure environment by intertext, and load other storage domain to some kernel module and strange root file system. And after this sequence, Qubes OS provides some function to access some file system to AppVMs. And cross-VM security is also important. Qubes OS has some cross-VM function such as clipboard sharing and file transfer via virtual disk. And cross-VMs have easily have some vulnerability and easily targeted. such as inserted rootkit at line migration and cross-VM side channel attack. This attack is a epic exploit, and this we can hardly to prevent it. Cross-VM side channel attack is estimates the access from another VM from response when malicious VM access physical cache continuously, and this exploit might steal some keys from physical cache. So Qubes OS is some protection of such attacks. This is a Qubes OS's file systems. First, Qubes OS application VMs have some read-only device. So when we load some virtualization environment is maintained by read-only device, and if we read or write some files, if Qubes OS demands some VM specific key, so VM's environment were maintained. And this is a summary of Qubes OS mechanism. Qubes OS is a domain-oriented VM and creates Xen VM per user's use. And seamless establish seamless operation by GUI Virtualization using Xen shared memory, and establish DMA protection by Intel VDD and also intertext, and establish protection by intertext, and also file system protection using is important, but it's then when Qubes OS uses VM specific key. And well, I'm not good at English, so I cannot tell you all about Qubes OS. Please see this Qubes OS overview and this, and see some documentations. Or so, do you have some? Do you anyone any questions?
What version of Xen is Qubes based on, or is it using today?
バージョンはベースにしてる Xen のバージョンは
ベースにしてる Xen のバージョンはそう覚えてないんですけど、Qubes I forget it, but Qubes OS is adds many functions to Xen, so it is different from original Xen.
Maybe older version of Xen based on.
Well, it's older version.
Does X0 domain also runs application?
Yeah.
Does DOM0 also run applications?
Domain zero is only provides secure environment and management module. So we can see application from domain zero memory, but domain zero will not execute some application.
So where is X server? Where is X server?
It's server on the domain zero, but from user to cannot use domain zero applications.
So applications from other domains use the domain zero X server.
Yeah.
これは、IaaS とかの、プロバイダーが提供する形を想定しているものなんです。
これは完全にクライアント向けなので。
クライアント向けだとちょっと正確にはちょっと把握しないんですが、ntddk ってジオンとかにしか、 TPM は最近載ってますけど、
はい、
TXT 自体の対応は結構
そうなんです。だから結構そのマシン自体の要求っていうのは結構厳しい。
The application domain use PV domain or HV? I think there is some domain which is not privileged domain called application domain.
Yeah.
And does it use ntddk or its virtualization domain?
Application domain, we can not use interpreted
X.
VTX, yeah. So
It doesn't use VTX in this virtual machine.
Yeah, I think so.
So it's only use VTD, but it never uses VTX.
So it only requires VTD and intertext, but feature is support added on interVTX.
Yeah, it is not directly related to QoS, but like 5 years ago or something, I saw a Solaris demonstration where it was possible to isolate groups of applications. And all application of each group was shown in the user interface with a color, very similar to this QoS. Do you know what is the technology behind that Solaris thing?
I don't know so about Solaris.
Is that containers?
Zones.
Yeah,
Zones.
yeah, I know about zones, and zones is very similar to jails, but I don't know if with the zones you can create run applications, all the applications sit in the same desktop, and each zone has a color like this.
Any other questions? Let me know. Okay, thank you.